Hi everyone, this is Dr. Vaughn again, making a short video for you with a couple of problems, this time from the start, a couple of sections from Chapter 5. So hope your week is going off to a good start. We're going to start with Section 5.1, and I chose one of the biggest and scariest looking problems from that section, number 72. So here we have two polynomials and we're subtracting them together. These are polynomials that have only one variable, x, and lots of different kinds of exponents and signs and things going on. The main thing you want to remember here is just to kind of get rid of the parentheses right off the bat and get things into just all pluses and minuses with no grouping symbols. So then you can start to collect the like terms together. So what I really want to do is turn this big subtraction problem into an addition problem, and I'll lose the grouping symbols. Now I can lose the grouping symbols on the first part because these are all individual kinds of terms. But on the second part, because of this minus sign, I need to distribute the minus 1 through each of the three terms in this grouping symbol. So that minus, the subtraction operation, gets applied to each of these three terms and not just the first one. And this is one of the biggest mistakes students make in this particular section, is they just drop the grouping symbol, they change the minus here and the minus here to a plus, but they forget that this minus sign actually has to apply to the other two terms. So we'll take care of that by just kind of simplifying this right off the bat. So first, we're going to distribute the minus sign. And you can also think of this as multiplying this through by -1, changing this plus -1 times all of these things and doing a multiplicative distribution if you want. All right, but this is going to be, the first term is going to be just the same. So let me go into my equation editor. And I'm going to go back up to this other one. I'm going to copy all the inside stuff from this first grouping. And I'm going to type that into my equation editor with a paste operation. But I've lost the parentheses, the grouping symbol that goes with it. Now I'm going to distribute this minus sign. So minus a minus 6 is going to become a plus x to the 6th. And a minus 2x to the 4th is going to be minus 2x to the 4th. And finally, the minus sign gets applied to the 2x squared, so we have minus 2 with the x squared. All right, and that's pretty much it. The only thing we have left to do now is to combine like terms. So anytime we have two variable terms that are exactly the same, even if the coefficients are different, we can combine them together. So we have minus 3x to the 6th and plus 3x to the 6th, and we can combine those together. Now I'm going to write the extra steps here just so you can kind of see what's going on. So we're going to write this as minus 3x to the 6th and we're just going to use the associative, the commutative property of addition to move the x to the 6th up to the front. Then we're going to do the x to the 4th term. So again, we had the 3x to the 4th. And we're going to subtract 2x to the 4th. And finally, with our x squared terms, we had minus x squared and minus 2x squared. All right, now one more in-between step, and eventually you'll be able to just kind of do this almost instantaneously in your head, is we're going to factor out the x to the 6th. So we have a minus 3x to the 6th and a plus 1x to the 6th. So we're going to write this as minus 3 plus 1 times x to the 6th. And similarly with the x to the fourth, we have a plus 3x to the fourth and a minus 2x to the fourth. So we're going to write this as plus. We'll put in our parentheses, and we have the plus 3 and the minus 2. So we combine the 3 and the minus 2 together, and those both go with the x to the fourth term. And finally, with the x squared, we have a minus 1 and a minus 2. Now I'm going to write this as a plus, and then I'll use the parentheses to write the minus 1 and the minus 2 together with the x squared. Now you don't have to do it that way. You could write minus and then do a plus 1 and a plus 2, but I find it easier just to kind of leave the plus symbol in between the groupings. Okay, so that's the in-between step, and finally we just combine the numbers together and write this as our final answer, which is the polynomial. So our final answer is minus 3 plus 1 is minus 2 x to the sixth. My 3 minus 2 is 1, so I don't even have to write a coefficient of 1. I can just write x to the fourth. And minus 1 minus 2 gives me minus 3 for the x to the squared, x squared. And that's our final answer for this particular problem. Now we're going to look at one other problem, which involves multiplying some polynomials. And I've already got it started down here at the bottom of the page, so let me move it up for you. Now we're going to look at problem section 5.4, and again problem number 72. This asks us to multiply this big scary looking polynomial times this big scary looking polynomial. The key thing to keep in mind here is that we got x's and y's and everything else. We just want to use the distributive property again. So by that I mean we're going to take this whole thing as if it were just one entity. This whole second polynomial with 3 terms in it is going to get multiplied through by the x squared, and this whole thing with 3 terms in it is going to get multiplied through by the plus 1. So the first step is to distribute from right to left the 3-term polynomial into the 2-term polynomial. So first we distribute the 3-term polynomial as follows. So we're going to get the x squared here gets multiplied by all of this stuff. So here's my x squared, losing the first grouping symbol. But I do want to leave the whole second things grouped together. So what I'm going to do is just go up here and copy this stuff again. And put it right into the parentheses over here. So that's the first term times all 3 of the second terms. And then you have the second term here, which is the plus 1, times all 3 of those second terms. Okay, so that's the first part of distributing the 3-term polynomial through the first binomial, which is the 2-term polynomial. Okay, now we distribute left to right. So what I mean by that is we're going to take this x squared and multiply it by the xy to the fourth, take the x squared and multiply it by the y squared, and take the x squared and multiply it by the plus 1. This one over here, when you multiply everything by 1, you just get the same stuff, because multiplying by 1 is the multiplicative identity, is the technical term. So all of this second part is going to stay the same. We're just going to lose the parentheses and the 1. It's this first one that we have to actually do something in multiplying through the x squared term. So let's go ahead and do that. So the first term becomes x squared times xy to the fourth, which we could either write out in that form or we could actually combine it together. X squared times x is x cubed, because you add the exponents when you have 2 things with the same base. And then your y to the fourth. Now we're going to take the x squared times the y squared. And finally, we take the x squared times the 1. And for the second part, we just have the inside of the parentheses, which is what I've been pasting in. It's xy to the fourth plus y squared plus 1. And if we look at this now, we don't see any like terms. There are no variable parts that are exactly the same. So there's nothing for us to combine together, and therefore we're actually done. We're fully simplified at this point. Anyway, that'll do it for this video today. Hope this has been useful. Have a great day.